to practicing LeetCode with me. Again, my name is Sim, and today we'll work on some problem. Start with something easy. Okay. Status to do. Buddy strings. I want to see how many downvotes this one has, because usually the ones with a lot of downvotes, not a good problem to do. I want to start with something that has as less downvotes as possible. X of a kind and deck of cards. Walking robot simulation. Okay, this one has too many downvotes. Let's see. Okay. All right, this one looks good. Let's do this one. So the problem is you're given an array of integers. Check if there exists two integers and an m such that n is the double of m. Okay, that's it. More formally, check if there exists two indices such that two different and I, j, and then I is twice as j. Okay. Alright. So an example, so 10, 2, 5, 3. And because 10 is double of m5, so we output true. So we output either true or false. True if there's such a pair of indices like that. Okay. So how do we start this problem? So like when you think of this problem, right? Usually we'll check all the possibilities, right? We'll check all the possibilities, all the combinations of pair of numbers in the array, and then we check if one is as twice as the other number. So you can have a for nested for loop, and then for I from 0 to n, where n is in the length of the array, and then inside that for loop you can have another for loop which is for j, so something like this, for I from 0 to n, and then you can have something like for j also from 0 to n, and then you can have a pair of ij, and then you can do a check on ij if the other is as twice as large as the other number. For this approach, this will take n squared, right? Okay. Can we do better? Can we do better or not? Let's see if we can do better than this. Is the double okay? One thing I can think of this, we can sort the array from small to large, but then we kind of have a sorted anyway, right? Yeah, we have to sort it anyway. Do you think you can do better than n squared? I mean, you can do in n log n. So first I sorted the array in n log n. Then for each number for like from 0 to n, I can binary search for the rest of the array to check for the number that is double the number that I'm at, so complexity would be n log n in overall. Can I do better than that? Can I do better than that? So in order to do better than that, I think we have to do it in O of n, right? We need to do this in O of n. Is it possible? Now let's think about this. Is it possible in an array of n numbers, you want to find two numbers in that array? So for example, 10, 2, 5, 3. No, I'll throw more numbers in here. I'll throw more numbers. See if we can find out anything. Something like that. Okay. If it's let's say if it's possible to find out those two numbers in one loop, how can we do that? Oh yeah, I think it's possible though, because like for each number you can have a hash set. So like if you see number 10, you can put in your hash set, which is 5 and 20. So your hash set would be something like 5 and 20, and then if you see a number in the hash set, you would return true immediately. And every time like that, you just put this number into your hash set. Yeah, that is one way of doing this. Then you will have your hash set, which is on space, because for each number you put like two numbers in your hash set. I think that'll work. But then the thing is, yeah, I guess that'll work. But if you want to save more space, you can just put 10 in here. And every time you see a new number, like if you see 2, what you need to do is you check if 4 and 1 is in the set. It's like you take 2 and you divide it by 2, and then or you multiply by 2, right? So I guess that's the solution for this. So that'll be O of n time and O of n space. Whereas the sorting method that I talked about in the beginning, it'll be n log n time and I think it's O1 space if you do the sorting in place. If not, you will have On space, and that doesn't make any better than this approach, right? You want to sort it in place in n log n, and then you have to do binary search. You have to do binary search for each number. Okay, cool. So let's do both approaches. So let's start with the first approach and see if it works. So I'm using Python, and let's say I have my set. Is it set like this in Python? I don't remember. Yeah, I think so. For number in array, what I want to do is every time like that, I want to put this number into the array, right? So I'll do s.add num. Is it add or push? I don't remember, but okay. Let's say it's add. And when do we want to return true? So we want to return true if num divided by 2 is in the array, right? In the set, or num multiplied by 2 in the array, and we want to return true. And at the end of the loop, if we cannot find such pair, we return false. Wait, is this? Okay, it's capital. What I'm wondering is, will this one return a, like, return like, like integers, or like, like 5 divided by 2, I don't know if it returns 2 or 2.5. I guess it's 2. But then in that case, we don't want it to happen, because here in this case, it doesn't evaluate that 5 is as twice as 2. So we cannot do that. So we can do something like, well, let's see. Okay, so if we have something like this, if num this, so take the remainder equal to 0, which is right, it has, okay, and this, okay, cool. All right, I think that's it. Let's run our code, see if it works. Okay, great. We submit. Wrong answer. What's happening? Okay, so the output is true. Expected is false. Why is it? So I see -2. I divided by 2, not in this. I put -2 in there. What's going on here? Well, I guess we have to debug this. Oh, there's a debugger. Oh, you have to pay. All right, let's run this. No, if it is returned true, one way we can debug this is when we can print the number out. We can print the number out before we returning true. I want to see what number that causes this. So that's 0. So that's 0. So what it says is 0 divided by 2 is in S. No way! How's that possible? How is that possible? How is this one? Oh no, see? My bad. Alright, we found the problem, guys. I think that's the problem right there. Now let's run our code again. See if it works for this case, and then submit it. Yay, there we go. 86% of Python faster than 86%. Great. All right, so this is the first method. I'll say like O n time. This is O n space. Now let's start with another method, which is O and login time, and then O1 space. Let's do this one. Guys, let's do this one. I'll comment these out, and let's do this one. Okay, for this one, so I think I'll sort it first. So I think this will sort the array in place in Python. And what do we want to do? We want to binary search, right? So we do it for number, for every number. I mean, we can either binary search for the whole array or just for the array that is larger for the all the numbers that are larger than the current number that we're at. So I think that's more efficient. It's still n log n though. So for I in x range of length of the array. So length of the array is just getting the length of array in case you wonder. So what do we do here? We have to, let's say, we will say if binary search, so we binary search this array okay, we'll binary search this array at index I. Okay. So let's see. How do you do binary search? Well, you can call recursion on each case. I'll just do binary search in this array at the index I. And if this return true, then I'll return true. It means that we found a match. And if not, return false. Like after this one, we couldn't find anything. So we have to define our helper for binary search, right? So we have self array and then an index I. So in order to do this, we kind of have to have binary search from index I plus 1 to the end of the array. We can do this by having a left and right pointer. So I can start with index and length of array -1, right? So that's what it is. Okay. Then what do we want to do? We want to see why left is smaller than right. Right, so we will, we will like narrow down our ranges. Like we can have middle equal to left plus right divided by 2. And then we compare this value with the what am I doing? Oh, we're comparing with this this value, right? Okay. If it's smaller, so let's say if the number we were trying to find, this one, if it is greater than the middle value, what do we do, guys? We'll find it in the half right, right? In the half right of the array. So that means we will reassign the left value, right? We will reassign the left value to the middle one, right? Else if, let's do this. This it makes more sense, because we're trying to see where does it lies. If it's smaller than the middle value, then we reassign the right to the middle. And then in the case if it is equal, means that we found a match. In that case, I guess we return true. And then after this search, if middle and right are equal, should we stop? I mean, in that case, we can do return if our array index equal to the array left or right, whatever. Okay. So we can do this. So this is the binary search to find if it is larger. Wait, something wrong. I'm trying to find the value that is twice as large. So, you know, we have to do something like value to find is twice as large, right? So it should be array at index times 2, and then you have to like compare this one. Okay. All right. And we can do this one equal to value to find. Okay. What are we missing? So we'll do this for 0 to the end of the array. Okay. If binary search, you can find it, then return true, not return false. Okay, let's run it, guys. I'm not really confident. Oh, okay. So I'm not really confident for this. See? No, it's wrong. I put true. Expected false. What are we missing? Oh, shit. Because I forgot negative numbers, guys. For negative numbers, this one doesn't work. This one doesn't work, guys. Oh, you see? This is the flaw of this approach. So, I think there are 2 ways we can fix this. One way is to divide our input array into negatives and then positive subarrays, and then we can do the check on each of those. Another way we can fix this is to let me see. Another way we can do to fix this. So let's say if I saw a number, we can do the checking here too. Like you can do the checking here. If it is a negative number, you can divide it by 2, and if it is a positive number, you can multiply by 2. Okay. So we can do the check right here. So we can have value to find at default would be multiply, because we'll think it is a positive number. But if, let's say, array at index is a negative number, then we reassign the value to find to be divided by 2. Okay. Cool. So we have to do something like so if it is smaller than 0, we can do something like if array index equal to 0, then we reassign the value, right? We reassign the value to find equal to array index divided by 2. But else, we can do this, you know. If it is not equal to 0, we can return false immediately, because like if you see like a -5, there is no way, there's no way that you can have like -2.5 in there. So else, then you reassign this value. I think this will work, guys. Finger crossed. Bam, time limit exceeded. What's going on? What's going on? Let's run with this case first. Okay. So what's wrong with this case, guys? We sort this one, so it'll be -19, -8, -2, and so on. So that it must have got stuck in an infinite loop. That's why. So I'm trying to see where. So usually we'll multiply by 2 to find that. So the infinite loop could be in here. It could be in here. So there's a chance that left and right got stuck. Okay. Oh, I see. Right here, guys. Our binary search is broken. So we have to reassign this to n+1. And then we have to reassign this to n-1, the middle. We don't care about the middle, because the middle is it's not equal. We can ignore it. It should work. It should work, guys. Okay, we got wrong answer. So it is outputting true, even though it is expecting false. What is going on? Okay, no worry, we can fix this. Brainstorm, guys. Why is outputting true? So if it is outputting true, we can print out what number this is. We can print out the number at this index though. My battery will run lows. Okay, so it is right at the first index, which is -19. Okay, that's strange. So if it is -19, I want to make sure that when it is returning true right here, I want to make sure that that's the value we're finding. So I'm going to print out middle. Wait, I want to find out what number that is. The value to find. It doesn't outputting anything. So maybe here we print out the value to find. Yeah, what kind of value to find? What is the value to find here? So the last one is 0. That is so strange. It got printed out 3 times. That means that it jumped to this binary search 3 times? Doesn't make any sense. Sorry guys. If self-binary search. This doesn't make any sense. Value to find. Oh my god. I'm getting stuck, guys. Left equal to right. Oh, I know why. Guys, this is so bad. Okay, we have to start from here. Left have to start from index +1. Okay, I guess that's a problem. We can rerun this. Index out of range. Shit. Oh my god, so many issues. So we can do if left smaller than length of the array, and okay, I guess that'll work. Yeah. Okay, so this one is lower, as you can see. It's 35%. But look at the memory usage. 12 megabytes, less than 100% of Python submission. You can see this is all one space. You guys see the trade-offs I made right there? Okay, we can polish this binary search to make it look better so it doesn't look clumsy like this. I think one way I can do to fix this is, let me see. Well, let's see. We can have something like this, smaller or equal. Then we don't need to have this one at the end. We can just return false right here. I think that'll work. Okay, guys, so we run this. Guys, see? That's not that bad. Look at the time. Like, it's faster than 61% of Python submissions. And the memory usage is less than 100%. This is gold, guys. Alright, I'll stop my video right here. And I'll see you guys in the next episode. How do I turn this off? I don't even know how to turn this off, guys. Okay.